This is pressure and hydraulics. We're going to look at the difference between pressure and force, which are two words which are used in everyday life quite often as if they mean the same thing, but they have very specific scientific meanings. We're going to look at hydraulic system, how it uses pressure to increase force, and we're going to try and do some calculations involving hydraulic systems. So starting this off, how is pressure different from force? This is a key thing to understand this little topic. Well, here's a little example. If you stand on a drawing pin, it'll really hurt. You only have to see that picture probably to go ow. But you can lie on a bed of nails, and although this guy's obviously trying to pretend he's really hard with his silly haircut and his very light block on top of him, actually anybody could do that. Okay, well, why is that? Well, it's because although the force is the same as putting all the weight on the pin, all his weight over these nails, the area is very different. So pressure has to do with force and area. It's calculated by doing the force divided by the area. Normally in science we'd use these units, newtons per metre squared. Sometimes we call that pascals, PA. Sometimes it's a bit easier to use centimetres squared for the area, so we'll get newtons per centimetre squared over here. Just as always, be a little bit careful with the units. So, how do we apply this? Well, here's our equation. Pressure equals force over area. Sometimes we want to reduce the pressure. So, for example, the tracks on a tank, or some snowshoes to stop you sinking in the snow, or a camel's feet to stop the camel sinking into the sand. All of these things have a large area. If we make the area big, we'll make the pressure small and you won't sink in. Sometimes we want to increase the pressure. We do that by decreasing the area. So some examples of that: the needle on a syringe, a shark's teeth, a sharpened knife. These are things that have a small area. If we get a small area, we get a big pressure. So now we've got the basic idea of pressure, we can look at hydraulics, which is a way of transmitting forces. You'll have seen this little demonstration. So we've got two syringes, one with a smaller area than the other. If we push them both with the same force, what's going to happen? Well, what happens is this one will win, if you like, the battle against this one. Imagine you're a little small piece of water in here. Which way are you getting most pressure? Well, the same force on a smaller area is creating a bigger pressure that way than the force on a bigger area at this end. So same force either end, small syringe has a smaller area, so a bigger pressure, so the water goes left. An important thing about hydraulics, if there's air in the system, well, you can squash air. Okay, so because air can be compressed, it doesn't transmit the pressure very well. If you push hard on both ends, you're likely to just end up with both ends going in and the air in the middle getting squashed. So here's the calculations on this. Okay, these sort of systems have what we call a master cylinder. This is the one where you're pushing, and they have a slave piston. This is the area that's getting pushed up on. If we put 2 newtons on here, how many weights can we lift on this side? Well, the way you do these calculations is you work out the pressure on this side first of all. So pressure equals force over area. We've got a 2 Newton force over a 4 centimetre squared area. Be careful, because as soon as some people see 4 and 2, they think the answer must be 2. But the pressure is the force over the area, so that is 2 over 4. 2 over 4 is 0.5. The second step of this calculation is always to state the pressure. There's a little clue for you, an exam technique here. State the pressure means don't work it out, don't do any calculations. The point is the pressure is transmitted, so if it's 0.5 at that end, it'll be 0.5 at the other end. Okay, final step is to work out the force on this side. Well, to work out the force on this side, we do the pressure. We've just got that is 0.5 times the area, 16. Okay, 0.5 times 16 is 8. Okay, so we've only put 2 newtons in, but we've got 8 newtons out. You can do this by ratios. Look at the ratios. 2 to 8 is the same ratio as 4 to 16, but do be careful if you're using ratios, because sometimes people get the wrong answer. But notice there's a little check. The force has gone up. That's the whole point of hydraulics.